right, guys, here we are at the whiteboard. So let's refresh our memories on our situation. So we are looking at an imaginary population of iguanas, and we want to know overall, is this trait of non-webbing, is it becoming more common in my population or not? And so non-webbing is dominant, so we represent with a big W, and then the webbing is recessive, so represent that with a little w. So you want to write that down so you can remind yourselves as we work through this. So let's say our population of iguanas, we have 500 iguanas. So you do want to know how big your population is in order to be able to calculate, what percent of that population has these different frequencies. And so let's say you brought out some geneticists and they helped you identify if, what their genotype was, what kind of alleles did they have. And let's say looking at our homozygous dominant iguanas. Let's say we went out there were 320. So these are all non-webbed. Let's say looking at our heterozygous individuals, our geneticists determined. That we had 160 heterozygotes. And then looking at our homozygous recessive individuals, let's say we had 20. So these are webbed individuals, and then these are, these are non-webbed individuals, and these are webbed individuals. Just to remind yourselves of that. All right, so the very first thing, the easiest thing to do first, if you have this initial starting information, let's say we don't know the frequency of our alleles, we want to get to that point. So we can use this information, knowing how many individuals are of different genotypes, to then get to our overall allele frequency. So I'll show you how to go ahead and do that. So the first thing we want to do is calculate the frequencies of the 3 different genotypes. All right, so that's just frequencies right there. So we want to calculate the frequency, or looking at what percent of my population is having the homozygous dominant genotype. So we had 320 individuals that were homozygous dominant. And to know what percent of that population, if there's 320 out of that 500, you want to do some simple division. So 320 divided by 500. So I did the math for you guys. This again is going to calculate what percent of my population is homozygous dominant. That is equal to 0.64. So going back to that Hardy-Weinberg equilibrium equation, this is representing p squared. All right. And then to look at the frequency, or what percent of my population is heterozygous, out of that 500, 160 of them were heterozygous. So again, you set up that simple fraction, you divide 160 divided by 500, that's equal to 0.32. And so this, in the Hardy-Weinberg equilibrium equation, is representing 2p². And then to look at the what percent of my population is homozygous recessive, what percent are webbed, we had 20 out of the 500 were webbed. And if you divide that out, you have 0.04. So 4% of the population of 500 iguanas had webbed feet. This is q squared. And so just to check your math, again, you want all of these 3 values must add up to 1. If you added these three values, they do add up to 1, so you know you did your math correctly. Pause. All right, guys. So just to recap, we just calculated the frequencies of the 3 different genotypes. So that way we can have that for future reference. So 64% of my population is homozygous dominant. 32% of my population, or 0.32, is my heterozygotes. And then 0.04, or 4% of my population, are homozygous recessive. All right, so before we get to our next step of this problem, because we want to now calculate the frequencies of the big versus little W alleles, dominant versus recessive alleles. In order to do that, we want to know, okay, how many total number of dominant and recessive alleles we have in our population. And to help us figure this out, because iguanas are diploid, and so therefore they have 2 copies of every single type of gene. So, whether it's a big W or a little w, they have 2 copies of every allele for that gene. And our initial population of iguanas was 500. So 2 times 500 equals 1,000 alleles. We need to know this value because we're going to be helping us use that value to then calculate the frequency of dominant and recessive alleles in this population for the webbed and non-webbed feet. All right, so that's what we're going to move on to next, number 2. Calculate frequency. We'll start with the dominant allele, big W. All right, so looking back at my 3 different genotypes, there are 2 different ways these iguanas could have at least, one of those dominant alleles. Either they are homozygous dominant, and so they're gonna have 2 copies of that allele, or they're heterozygous too. We don't want to forget about our heterozygotes. So they have, at least one of those copies of those alleles. So going back to our initial population size or initial population number breakdown for these different genotypes, we had 320 out of the initial 500 iguanas, again, that were homozygous dominant, just to remind ourselves of that. And so find out how many alleles out of the 1,000 are just within these individuals. In order to be homozygous dominant, you have 2 copies of that dominant allele. So to find out how many alleles that is total among just these individuals, you'll take how many people there are and times that by 2. Remember, every individual has 2 copies of that gene. To find out the total number of alleles within this group, 2 times how many there are. And that is 640. So within the homozygous dominant, we have 640 alleles there. But again, don't forget about the heterozygotes. Going back to your initial notes, we had 160 individuals, 160 individuals that were heterozygous, and they have 1 of those dominant alleles. So therefore they have, within these individuals, there are 160 dominant alleles among them because they only have 1 copy each. So to figure out the total number of just the dominant alleles, we're going to take these 2 numbers together and add them. And once you calculate that, that is 800. So out of the total 1,000 alleles within this gene pool for this trait, 800 of them are dominant, which makes sense because a good chunk of our population are either homozygous dominant or heterozygous. So now to get to our last step of this, number 2, we want to figure out the frequency of the dominant allele. So and then again, we know 800 out of the 1,000 are dominant. So to figure out the frequency, Again, do this simple division. 800 divided by 1,000 will then tell you the frequency of the dominant allele in your population. What percent of my population has this dominant allele for non-webbed feet? That number is 0.8. So that is the frequency of the dominant allele. That takes care of step 2. So I know sometimes we might get lost in our calculations. Again, all we're doing right now in this first half of this worked example is figuring out our initial population, because we need to then figure out later has it changed. This is just the initial population. So our last little step here is we want to calculate the frequency of the recessive allele. Move down. Oopsies. So frequency of the recessive allele. Again, looking at my genotypes, there are 2 different ways to have at least one of those recessive alleles. Again, don't forget our heterozygotes and then our homozygous recessive individuals. So, looking back at our initial numbers, the heterozygotes, they had one of those recessive alleles. Again, there were 160 individuals that had one of those recessive alleles. And then our last way to get that recessive allele is the homozygous recessive individuals. And we had 20 individuals that were homozygous recessive. But remember, they have 2 copies of that gene. So to know the total number of alleles of this recessive allele within just these individuals, 20 times 2. So to know the total number of the recessive alleles, so total of the recessive alleles, you add up these 2 values, 160 plus 40, and then therefore you get 200 alleles. So out of those total 1,000 alleles, 200 of them are the recessive allele. So to know the frequency of the recessive allele, we'll do the exact same thing. We'll divide 200 divided by 1,000. And so my frequency of my recessive allele then is 0.2. So you want to just make sure you double check your math, because remember the frequency of the dominant and recessive allele, P plus Q, must add up to 1.0. So looking at my P and my Q, yep, they both add to 1.0. So my math is correct. Again, meaning that it's 1.0 does not mean it's in Hardy-Weinberg equilibrium. It just means I did my math correctly. All right, stay tuned for our second half.